Friends, good evening and welcome to the second session of the program on dairy technology. This I will be discussing part 1 of your third course, which is milk processing and packaging. Now in this course there are 4 blocks. First block is regarding reception of milk. Second block is regarding processing of milk. Third block is regarding packaging of milk. And the fourth block is cleaning and sanitization of dairy equipment. So in this session I will be discussing with you the first 2 blocks, the reception of milk and the processing of milk. Now these 2 blocks have 8 units. The first block, which is reception of milk, has 3 units. First unit is regarding the collection and transportation of milk. The second unit is regarding reception of milk at the dairy dock, and third is chilling and storage of milk. Now the second block has 5 units. First unit is regarding the special treatments which are given to milk in the plant. These are clarification, the separation of fat, the standardization and bacteriophagization. Second unit is regarding pasteurization of milk. Third unit is regarding homogenization of milk, and fourth unit is regarding sterilization of milk, and the last unit, which is the fifth unit, is regarding the sanitization and cleaning of the milk processing equipment. So the first, milk reception and processing. The milk production is confined to rural areas in India, while the demand for milk and milk product is mostly in urban areas. This is the special feature of the Indian dairy industry. Second is, milk has to be collected, transported and marketed from villages to town, cities. Milk after collection must not take more than 4 hours for chilling, otherwise the quality will deteriorate. Now collection point must comply with the same hygienic requirements as the dairies or the dairy plant. Then milk reception, as I have told you, has 3 blocks. First is 3 units. First is milk collection and transportation. Second is milk reception at the dairy dock, and third, milk chilling and storage. So I will be discussing them one by one. First, the planning of milk collection. Now the planning of milk collection in India is different from other countries because of the certain specialties in Indian conditions. Is the climatic condition, which is the climate is hot and humid in India. Then development features, our infrastructure of road and other things is not as developed as in other dairy countries or in Western countries. Then inheritance characteristics of milk. Milk is a very perishable commodity. If it is not collected and transported in hygienic condition, then there may be deterioration of the quality of milk. Then the size of dairy plant. The collection is planned. Collection of milk is planned according to the dairy plant. If plant is small, collection may be from nearby areas. If plant is larger, then collection may be from far away places also. Because in India, the production of milk is every producer has 1, 2, 3 animals. So it is a small milk which is produced by a single producer, and then the production is scattered in wider area. Then distance from market, dairy plant, the long distance means sometime milk has to travel before it reaches to the processing plant. Then the type of product, we have to take into consideration the type of product to be manufactured. Say for example, if you are manufacturing the market milk or the cheese, then the quality of the milk which is reaching the dairy plant should be of very high grade. On the other hand, if products like you can say khoa, paneer, etc. are produced, or ghee is produced, then even the quality, which is not as high as in the case of market milk or milk which is used for cheese, may be you can say received. Then the second is, what are the objective of the, what should be the objective of the collection of milk? These are accurate measurement of producer's milk, because if the measurement is not accurate, then the producer will not be satisfied and they may stop giving the milk to a particular dairy plant. Then receipt of unadulterated, clean, hygienic and good quality milk. The objective, second objective, which is you can say most important from the dairy plant point of view, is reception or collection of unadulterated milk, clean milk, hygienic milk and the good quality milk, because only then you can supply good quality market milk or good quality milk products to the consumers. Then regular and timely payment to the producers. As the producers, they are very poor in our country, the timely payment, regular and timely payment should be there, otherwise they may not give milk to the dairy plant, they may give to the private contractors, which give them payment at the when they receive the milk itself. Then incentive for quality milk. As we know that in our country, which is hot, the climate is hot and humid, the quality of milk deteriorate very quickly. So if the initial quality of milk is not very good, then there may be further deterioration in the quality of milk because of the microbial growth. Hence, we should give the incentive to the producers for producing milk of better quality. Then economic collection and efficient transportation to the plant, means this should be the objective, that the collection should be as economical as possible and very efficiently. Once the milk is collected, it should be transported to the processing plant. So these are some of the objectives of the milk collection system. Then step involved in milk collection, the steps which are necessary, they are milk survey and location of milk shed area. The milk procurement officer, he should conduct a survey and he should know about the location of milk shed area, a particular area from where the milk has to be collected. Then second step is establishment of collection points. The third step is deciding a milk collection route. Means, as I have told you, that the transportation of should be very efficient as well as it should be very economical. So for that, the milk collection route should be very accurate. Then management of the organization. Next step is first the dairy plant or the management of the plant will organize the collection system, and then there will be supervision or control of that system. So these are some of the steps. Then type of milk collection, how the milk is collected from the producers. These are some of the means. First is direct from the producer. Milk is collected directly from the producers by the dairy plant or the personnel of the dairy plant. Now in this system, you are in direct contact. The advantage is that you are in direct contact with the producers. You know about their problems. You can influence them to produce milk of better quality. The disadvantages are that, as I have told you, the producers, they are widely spread and the production of milk is very small by a single producer. So you cannot reach, it is very difficult or it will be very expensive to collect the milk from individual producers. So second system is through middlemen. Middlemen are appointed and then the milk is collected from these middlemen. So in this case, you can reduce the cost of collection of milk, as you are collecting from few people only, instead of collecting from so many producers. But the problem in this case is that the middleman may cheat the producer as well as the plant. So this is not the very efficient system. Third is through agent or contractor. This is also same as the middleman. Few contractors are appointed by the dairy plant, and then those contractors, they collect the milk, they transport the milk, and they are chilling the milk, and they are giving the milk at the dairy plant. In this case also, in this system also, same problems are there, that the producers and the milk plant are cheated by the contractor from quality wise, the milk quality wise as well as the price wise. Then the fourth system is through cooperatives. Now in this case, the cooperatives of the milk producers are formed, and these milk producers, they will be bringing the milk to the common points where these cooperatives will be collecting milk. They will testing the milk for fat percentage or SNF percentage. They will be making the payment to the producer, and they will receive the payment from the milk plant. Now this system has been considered the best system of milk collection, and it is known as the Amul pattern of cooperative system, that the milk producers, they make their cooperatives, and the milk is collected by the cooperatives. One secretary is there and then collector or a person is there who arrange all the collection and payment to the producers. Then the fifth method is directly from dairy or chilling center. Instead of collecting the milk from the producer, the plant collect the milk from other dairies or the chilling center. In this case, the advantage is that you need not to have the infrastructure, you need not to go to several producers, and the collection is easier, but you have to pay more for the chilling center or the dairy plant compared to what you pay to the producer. Then the other system is through government agencies. As government in India, Indian government is giving the very much importance to the development of dairying in India. The government gives incentive to the farmers or the producers by collecting their milk and marketing it to the dairy plant. So this system also can be used for collecting the milk from the producers. Then next thing comes container for milk collection. How the milk is collected, what are the containers? Now depending on whether the milk is on the farm, collected on the farm, whether the milk is collected from the producer, small producers, or whether it is for pickup points, or whether the containers are for chilling center or collection center, or they are for bulk milk storage. Different type of containers are there depending on where you are using these containers for the collection of milk. Then comes the transportation of milk. The transportation of milk is affected by several factors like geographical location of the plant and the producers, volume of milk, how much volume of milk has to be transported from the collection center or chilling centers to the dairy plant, then variable resources, then cost of transportation. The cost of transportation also, if it is going very high, then the milk, market milk or the milk products which you are selling in the market, you will be selling at higher price, which may not be competitive to your other fellow plants or the person who are selling the milk. So you may not be, your product may not be cost effective. Then distance of transportation. It also depends that how much distance you have to cover from the milk collection or chilling center to the dairy plant. Then condition of road in India, at several places the condition of road is not very good. So while transporting the milk, you have to take this thing also, the condition of road, into consideration. Then mode of transportation. The milk is transported from the producers or from the collection center to the milk plant or to the common points where the truck of the plant will come and collect the milk by different means. Head load, where there are no roads, the milk producers will take the milk on their head or shoulders in a small bucket or can. Then soldier sling, tonga by tonga, also milk is transported. Then pack animals like donkeys or horse, or the camels, or bicycles, it is transported from the village to the milk plant, or by the motorcycles. The cans are taken on motorcycles and the milk is taken from the collection center to the processing plant. If the quantity is not very large. Then through boat, where there are, you can say, the milk, the water bodies are there, say canals are there or rivers are there, then milk transported by the boats or motor trucks. If quantity of milk is more, then motor trucks or railway wagons or road tankers or rail tankers are used for the transportation of milk. Then comes the reception of milk, the checking of the quality at the collection centers or at the dairy plant. Organoleptic test you have to conduct, which include smell or odor of the milk. You have to take whether the milk is acidic or not. It will give you idea regarding that. Then you have to take see the appearance of the milk. If something is added, foreign matter or dirt or dust or extra particles or hair of the animals are there in the milk, by appearance you can see those things. Then taste of milk, the developed acidity is there. Then by taste you can judge whether the milk is fresh or it has become acidic. And by observing the temperature with your finger, you can judge whether the milk is cool or it is hot. So if the temperature is higher, then there are chances that there may be microbial growth. Then COB test is there. This also comes under from test. Clot on boiling test. You have to take a small volume of milk, say 5 ml milk, in a test tube, and you have to heat it on open flame. If milk is not of very good quality or if developed acidity is there, the milk will get coagulated. So we say that positive COB test is there and milk should be rejected because you cannot process this milk. Then the other organoleptic test is the alcohol test. You have to take 5 ml milk in a test tube and then equal amount, means 5 ml, 95% ethyl alcohol is added, and after thorough mixing by shaking the tube, you can observe tiny clots in the test tube if the quality of milk is not good. This test is conducted to judge the heat stability of milk, to know the heat stability of milk. If milk is not of sufficient stable to heat, it will coagulate when it is mixed with the alcohol. Then the other test is titratable acidity. You can titrate the known amount of milk, say 10 ml, with N by 10 NaOH, and you can know that whether the milk is acidic or not. Then you can determine the pH of milk. That will also give whether the idea whether the milk is acidic or not. Then lactometer reading you can take, which will give you the idea about the specific gravity and fat percentage if no water is added. Then sediment test is carried out to know if there is a foreign matter, dust, dirt, etc. in the milk. Then allergen alcohol test is there. This is also conducted to know the quality of the bacterial quality of the milk and also the heat stability. Then after the organoleptic tests are completed, the second stage comes the laboratory test. These are the fat test, whether the milk has the required amount percentage of fat or not. Then total solids are estimated gravimetrically or through lactometer. Then you can calculate the after taking the lactometer reading, you can calculate the total solids. Then microbiological tests like MBR, Rezurin test, and the total plate count, etc. are taken. And in addition to that, if there is a doubt that milk has been adulterated or some neutralizers or preservatives have been added, so you have to conduct the additional test for adulterants, preservatives and neutralizers before the milk is accepted or rejected. Once the milk is received at the dock of the plant or dairy, then the next step comes the chilling of milk, so that there is no further deterioration of the quality of milk through the growth of microorganisms. The importance of chilling is this effect on the quality microbial growth, and also it affects the keeping quality. And also there is an effect on physico-chemical properties of the milk. Say for example, when milk is chilled to 4 degrees centigrade or lower than that, there will be no further microbial growth. So if the initial quality of the milk is good, milk can be stored for 2-3 days at this temperature, 4 degrees centigrade or less than that. So there will be no further growth of the microorganisms. So keeping quality is affected, means it is increased. Then there is an effect on physico-chemical properties of milk by chilling. There is a effect on protein as the milk is chilled, the beta casein get dissociated from the micelle. And if the milk is not warmed, say at 40 degrees centigrade for 10 minutes or so, the yield of cheese will be lower and the firmness of the curd during the manufacturing of cheese will be less. So there is a effect on the milk protein. Similarly, chilling affect the milk salts. The milk salt are present in milk in its naturally, when the milk is in its natural state, as it is drawn from the udder of the animal. The milk salt, they are present in 2 different forms, the soluble form or the dissolved state and the colloidal state. In dissolved state, the milk, the minerals are present in the water phase, and in the colloidal state, the minerals are associated with the milk proteins. So when the milk is chilled, the colloidal minerals are shifted to the dissolved state, and as a result, the clotting of milk either by addition of acid or addition of rennet will be slower. It will take longer time. Failure to rennet acid coagulation, milk may not clot with the addition of rennet or acid, or it may take longer time to get coagulate. Then failure to coagulate at isoelectric point, milk may not get coagulated at isoelectric pH, which is 4.6 but you may have to decrease the pH to lower value, which is about 4.3. Milk will get coagulate. Instead of at pH 4.6, it will get coagulate at pH 4.3. Then there is an increase in viscosity as a result of chilling of milk, decrease in curd firmness, increase in hydrolytic rancidity, because due to chilling, the lipase which is associated with the fat globule membrane get dissociated from it, and it comes into the serum phase, and there are chances that the hydrolytic rancidity may develop in the milk. Then increased foaming is there in the milk. Then physical structure of fat globule is changed because of the chilling. The agglutinins which cluster different globules together is more effective, and hence there is an increased clustering of the globules. Then migration of substances are there from the colloidal state to the dissolved state. As I have told you, in case of minerals, similar is the case with proteins, particularly casein. From the micelle, it may migrate to the dissolved state, or the micellar casein may change into serum casein. Then method of chilling. Different methods can be adopted, as has been told by Dr. Saluja in the earlier session, that container immersion. The can be immersed in cold water. Then surface cooler can be used to chill the milk. Then plate heat exchanger can be used, as it is in the case of pasteurizer. Then tubular cooler can be used, and bulk milk cooler, in which the double walled pan is there, agitator is there, and the milk is filled inside the container, and the double walled cold water is circulated. Then root freeze, or putting ice direct into the metal can, also the milk can be cooled. Then in can cooling, in can either you can add the ice or you can supply the refrigerant. Then direct addition of ice, mechanical cooling, as it is in household refrigerator, surface immersion cooling, expansion of bulk cooling, and ice bank. Then chilling center, you have to, as I have told you, that milk should reach the dairy plant, or milk should be chilled after its collection within 4 hours. It should not take more than 4 hours, otherwise the quality will get deteriorated. So if it is not possible to transport the milk within 4 hours to the milk plant, then you have to establish chilling centers, and the location of these chilling centers are affected by location of main dairy or the market, within the area of adequate potable water, the chilling center, whereas you want to establish the potable water should be available in plenty in that area, sufficient electric supply should be there, proximity to good road, railway station should be there, so that once the milk is chilled, it can be, or the milk can be, after collection, immediately it can be brought to the chilling center. Then facilities of waste, sewage disposal should be there, easy availability of human resources should be there. So by considering all these things, you should establish the chilling center. Then processing of milk. Once the milk is received in the dairy plant, all the tests, organoleptic and the laboratory tests are conducted, and milk is accepted. Then there is a processing of milk. This is the second block, and this involves certain treatment like clarification, separation, bacterifugation, and standardization. Clarification is done to remove the foreign matter which is present in milk. This is nothing but a centrifugal type of equipment in which the foreign matter is removed from the milk by centrifugal force. Then separation of milk is done, means the cream is separated from the milk, so that the cream which you get and the skim milk can be used for further production of different products or even market milk. Then lactofiltration is a treatment which is given to milk to remove or to reduce the bacteria which are present in milk, and this is done again by subjecting the milk to centrifugation force. Then there is a standardization of milk. The milk is standardized to a predetermined fat and SNF percentage. Say for example, if you want to produce the toned milk, then the fat percentage should be 3 and the SNF percentage should be 8.5. So you have to standardize in such a way. Then the second unit is regarding pasteurization of milk. Now pasteurization of milk is done to improve its keeping quality, and it is done in such a way that if the milk, after the milk is purchased by the consumer, even if it is not boiled, the consumer can consume the milk without boiling. So pasteurization is nothing but it is the destruction, or you can say the killing of pathogenic microorganisms which are present in milk. It may not remove all the bacteria or microorganisms from the milk, but definitely it will kill all those pathogens which are present in milk. Now, then next unit is regarding homogenization. Milk has to be homogenized before it is distributed to the consumers, either in the form of a market milk or a special milk like the flavored milk or flavored sterilized or fruit flavored milk, etc. Then the fourth unit is regarding sterilization of milk and the UST processing, which is done. The aim of sterilization and UST processing is to make milk free from all the microorganisms and their spores. Then fifth unit is regarding preparation of designated milk like the tone milk, standardized milk, full cream milk, etc., and double tone milk, and then special milk like flavored milk, then the fruit flavored milk and the flavored sterilized milk, etc. We will discuss them one by one. First, the pasteurization, the definition and objective of pasteurization. The definition of pasteurization as per the PFA is heating every particles of milk to a temperature of either 63 degrees centigrade for 30 minutes or at 71.7 degrees centigrade for 15 minutes in properly designed equipment. Milk is immediately cooled to 4 degrees centigrade or below than that and stored in a cold storage at 4 plus minus 1 degree centigrade, so that once the pathogens are destroyed, the microbes, other microbes which are there in milk, they should not multiply in number. Then this is the PFA definition. The IDF, International Dairy Federation definition for pasteurization is that pasteurization is a process applied to a product with an objective of minimizing possible health hazard arising from pathogenic microorganisms associated with milk by heat treatment, which consisted with minimal chemical, physical and organoleptic changes in the product. The heat treatment suggested by IDF for pasteurization of milk are 15 seconds at 71.7 degrees centigrade or 30 minutes at 62.8 degrees centigrade. These temperature time combination can be regarded as universal reference treatments. So then the type of pasteurizer, we have two types of pasteurizers, as I have told you. Either the milk was pasteurized at 63 degrees centigrade for 30 minutes. That is done in holding type of pasteurization. You can see the diagram. This is a double jacketed, you can say, container in which the milk is taken, and in this there is the steam, hot steam is supplied, and the milk is agitated or mixed while being heated. So milk is heated at 63 degrees centigrade for 30 minutes. And then second type of pasteurizer is STST, high temperature short time pasteurization. In this, milk can be pasteurized continuously. It is not holding time, but it is a continuous type of pasteurizer. You can see the diagram, and flow diagram is given here. In this, you can see that different steps are there. First, the milk is received, then it is heated, and there is a regeneration valve. If milk do not receive sufficient heat treatment, as it is given in the definition that every particle should be heated at 63 degrees centigrade or at 71.7 degrees centigrade for sufficient period of time. So there is a you can say flow diversion valve. If milk is not heated sufficiently, it is rediverted and again it is heated. Then test for pasteurization efficiency. Whether the pasteurization is efficient or not, there is a phosphatase test. Means why we have decided that milk should be pasteurized or it should be heated at either 63 degrees centigrade for 30 minutes or at 71.7 degrees centigrade for 15 seconds. There is a reason for that, and the reason is that the pathogenic microorganism which is most stable, that is the tuberculosis bacteria. So that is destroyed at these temperature time combinations, and at the same temperature time combination there is a phosphatase enzyme in milk, alkaline phosphatase enzyme. This is also destroyed at the same time temperature combination. So to judge the efficiency of pasteurization, the alkaline phosphatase, a natural enzyme present in raw milk, is simultaneously deactivated by heat treatment as specified for pasteurization. Raw milk is taken and p-nitrophenyl disodium orthophosphate is added to that. After addition to this, if milk is incubated, then there is a yellow color development. Milk change into yellow color, and this is because of the release of para-nitrophenyl from the milk. And if the milk, on the other hand, if milk is efficiently pasteurized, then there will not be release of this para-nitrophenyl and yellow color will not be there in the milk. So by this test you can judge the efficiency of pasteurization. Then next unit comes regarding the homogenization of milk. Homogenization of milk is a homogenized milk is a milk which has been treated in such a manner so as to ensure breakup of the fat globules to such an extent that after 48 hours of storage, no visible cream layer occur in the milk, and the fat percentage in the 100 ml top layer, 100 ml, in a quart bottle, which is about 946 ml, the typing mistake, 946 ml or a quart bottle. If you take top 100 ml milk, then the difference in the fat percentage of that top 100 ml and rest of the milk should not be more than 10%. If it is less than 10%, then you can say that milk has been homogenized efficiently. Then theories of homogenization. What are the theories of homogenization or principle of homogenization? How milk is homogenized? There are different theories. The searing and grinding. When the milk is, you can say, forced to, you can say, travel through a very fine valve, homogenizer valve, then there is a searing and grinding of the fat globules, and they break down to a smaller size up to their 1/10 of the original size. One is this theory. Then second theory is regarding exploding. When milk is forced through the homogenizer valve, which is very fine, it is forced through a very high pressure. When after leaving the valve, the pressure is released, then because of the very high pressure inside the fat globules, they are explode, and they are just broken down to a smaller size. Then third theory is regarding splashing or shattering of the fat globules. As there is a difference in the pressure, once the static pressure is there, when the milk goes into the homogenizer valve, then it goes at high pressure, and again when it leaves the homogenizer valve, the pressure is decreased, and as a result of this, milk at a very, you can say, high velocity, it just stuck to the walls of the homogenizer, and as a result of this, there is a breakdown of the fat globules. Then there is a acceleration deceleration theory. It is because the velocity is static, then it is a very high velocity when the milk is in the homogenizer valve, and again when it leaves the homogenizer valve, again there is a decrease in the pressure. So there is a acceleration, deceleration, and because of this, the fat globules are broken down. Then there is a the other theory is regarding cavitation of the milk. In this case, when the pressure is released, then the foams are formed, and these foams, because of the decrease in pressure, they explode, and as a result of this, the fat globules which are present in these foams, they are also broken down. Then advantages of homogenization. The homogenization prevents separation of fat, cream form milk. There is no formation of cream layer, no separation of fat, result in soft curd formation and hence better digestibility. Then churning of fat is prevented during transportation. Provide uniform distribution of fat, uniform consistency is there of the milk, prevent development of oxidative rancidity. It is decreased. Then disadvantages of homogenization are possibility of incorporation of foreign fat. You can mix the foreign fat and homogenize the milk, so it becomes easier. The adulteration of milk with foreign fat. Then development of sunlight flavor is there due to hydrolytic rancidity, as the enzyme is released from the milk or the fat globule membrane surface. The lipase is released during homogenization. So if the temperature is not sufficiently high, there are chances that there will be sunlight flavor. Then the homogenized milk is difficult to utilize because fat separation cannot be done. Then new innovation in homogenization, high pressure homogenization, then conventional wall type either or microfluidization, and then vacuum homogenization. These are the new innovation in the homogenization. Then factor affecting homogenization efficiency, type of valve. If grooved valve is there, the efficiency will be better. High pressure gives better efficiency. Then whether it is one stage or two stage gives better efficiency. Then fat content, if high fat content is there, efficiency is decreased. And temperature, if high temperature, the efficiency will be better. If temperature is between 60 to 70 degrees centigrade, then efficiency will be better. And if high fat percentage is there in milk, even temperature can be increased beyond 70 degrees centigrade. Then effect of homogenization of physicochemical properties of milk. The homogenization affect the physicochemical properties. The fat is affected, fat globules are decreased, so there is no formation of fat layer or cream layer. Then proteins are also affected, means when there is an increase in the surface area, protein from the serum phase or colloidal state, they migrate to the surface of the fat globules. Then color, more whiteness is there in the milk. Then emulsion stability, there is no separation of fat, so emulsion is more stable. Curd tension is decreased, and heat stability is decreased, viscosity is increased. These are some of the effects. Then we have sterilization. Sterilization is done to kill all the microorganisms and their spores in the milk. Similar is the effect of UST processing. It is done at 125 degrees centigrade. Milk is heated for 2 seconds. In case of sterilization, milk is heated at 110 to 20 degrees centigrade for 10 to 30 minutes. And the object of both the treatment is same, to kill the microorganisms, all the microorganisms, whether pathogenic or non-pathogenic, and their spores. Then type of sterilization: plant, direct heating plant, infusion type, injection type, then indirect heating, plate heat exchanger, tubular heat exchanger, then scrapped heat exchanger. Then toned and double toned. These are some of the designated milk. The toned and double toned milk. Toned milk is the brainchild of Dr. D.N. Khorodi. It was prepared to increase the or tone the supply of milk. Toned milk is that milk which contains 3% fat and 8.5% SNF, and double toned milk contains not less than 1.5% milk fat and not less than 9% SNF. Then this is the flow diagram for the toned milk. Then we have recombined milk. Recombined milk refer to the product obtained when butter, oil, skim milk powder and water are combined and corrected, and then we have reconstituted milk and also the flavored milk. So friends, I have discussed these two blocks in short, and if there is any question or any doubt, you can ask. If not, then thanks a lot.